About group layers, we talked about stacked group and color filter group layers. So only multi-domain group layer is left. From now on, I will tell you the multi-domain layer by using an offset option. Before start, I will explain the two methods to set the loving condition. It is the TechWiz LCD 2D which can generate a 2D structure. First, how did we define the loving condition when we generate the simple IPS example? That is case A, by assuming that the electrodes are always perpendicular to the screen. And accordingly, the loving angle of the LC should be set. But there is another method to set the loving condition, case B. Enter the tilted angle of the electrode itself and use the LC loving angle of the existing process as it is. The tilted angle of the electrode is called offset angle, and it can be set in the simulation condition. We already talked about the case A, so let's take a look at the case B, generating a super IPS structure using multi-domain and offset functions. So, to check the results quickly, I will delete the color filter group layer. Please look at this figure. At first, I will tell you the simulation flow. The simulation area is divided in two domains, domain A and domain B. At first, set the structure information of domain A and make it as a stacked group layer A. As the same way, define the structure information of domain B and make it as a stacked group layer B. Lastly, combine them as a multi-domain layer. So, let's define a domain A. We will use the structure information used in the simple IPS example as it is. Select all the layers and then combine them into the stacked group layer. I'll modify the name as domain A. Since the structure information of domain A and domain B is the same, we will use the copy and paste function. Just copy and paste it. And then I will change the name as domain B. After that, combine them as a multi-domain layer. And let's set the loving condition. As an offset angle is applied, input the loving condition of LC for the existing process. So, azimuth angle of LC should be set as 90 degrees. Therefore, I will modify the azimuth angle of surface orientation as 90 degrees. Domain B is the same, so I will change it. We will define the offset angle, which is tilted angle of the electrode. So as the same reason, enter 0 degree and 90 degrees for the phi angle of the top and bottom polarizers. And the next one is an offset angle condition. Based on the reference goniometer, domain A is the state where the electrode is tilted minus 12 degrees. So the offset angle of domain A is minus 12 degrees. Domain B is the state where the electrode is tilted by 12 degrees. Therefore, the offset angle of domain B is 12 degrees. If you click multi-domain group, there is an offset angle condition. So I will enter the offset angle for the domain A is minus 12 degrees. And for the domain B, enter 12 degrees. And there is a ratio condition. In this condition, you can define the area ratio of each group layer. I will set the default value of 1 to 1. So, all of the condition settings are done. I will save it as a multi-domain. And then click Run button. The voltage application conditions set in the electrodes of domain 1 and domain 2 appear as follows. Select the main voltage condition as a reference for the result. In this case, it is the same, so I will click domain A and then click OK button. When the calculation is completed, 2D viewer is opened automatically. Let's check the polar chart of transmittance for each domain and total domain. Click the polar chart tab. In the domain, there is a total domain, domain A, and domain B. I will compare the results for domain A, domain B, and total domain. At first, I will select domain A. And display type is transmissive. Data is transmittance. Click plot. And then as the same way, I will select domain B and click plot. Lastly, I will select total domain and then click plot. If you click this tile windows, you can compare the three results in one screen. Let's set the voltage condition. This is domain A. And this is domain B. And this is total domain. Therefore, you can see that domain A and domain B show transmittance results tilted in a specific direction. On the other hand, in the total domain, the optical characteristic is very similar for all viewing angles. So, if you compare them, you can clearly identify the difference of the results. And here are some examples which show the difference in contrast results depending on whether or not offset is used. When offset function is not applied, we assume that the electrodes are always perpendicular to the screen, and accordingly the lobbing angle of the LC should be set. Therefore, the reference axis is quite tilted in one direction. But when entering the offset function, the result is output in the same form as real one. So with some examples, I have finished the explanation about TechWiz LCD 2D. Thank you for listening.